Download this code from codegive.com, link in the description below. Understanding and handling new connection error in urllib3. The new connection error is an exception raised by the urllib3 library, a powerful and commonly used HTTP client in Python, when it fails to establish a new TCP connection to a server. This error typically occurs when the client is unable to connect to the server due to network issues, incorrect host name, firewall restrictions, or the server being down. Understanding the root causes of this error and implementing appropriate error handling is crucial for building robust and reliable applications that interact with web services. This tutorial will delve deep into the new connection error in urllib3, exploring its causes, providing code examples to demonstrate how it occurs, and offering various techniques for handling and preventing it. What is urllib3? Before diving into the specifics of new connection error, let's briefly discuss urllib3. It's a Python library that provides a thread-safe, connection-pooling HTTP client. It is used by many popular Python packages, including requests, making it a foundational library for making HTTP requests. urllib3 handles connection pooling, retries, and other complexities of HTTP communication, allowing developers to focus on the application logic. Understanding new connection error. The new connection error is a subclass of urllib3.exceptions.max retry error, which itself inherits from exception. It specifically signals that the connection couldn't be established after the client has exhausted its retry attempts. This error typically indicates a problem at the network layer rather than with the HTTP protocol itself. Common causes of new connection error. 1. Incorrect host name or IP address *. Problem *. The host name specified in the URL is incorrect or the DNS resolution fails to find the IP address associated with the host name. Example *. A typo in the URL, an outdated DNS record, or a recently changed server IP address. 2. Server not running or unreachable *. Problem *. The target server is not running, is overloaded, or is temporarily unavailable. Example *. The web server is down for maintenance, experiencing a high load that prevents it from accepting new connections, or has crashed. 3. Firewall restrictions *. Problem *. A firewall on the client's network, the server's network, or in between is blocking the connection. Example *. The client's firewall is configured to block outbound connections to specific ports or IP addresses, or the server's firewall is configured to prevent connections from certain IP addresses. 4. Network connectivity issues *. Problem *. The client machine is not connected to the internet or there are network issues preventing communication with the server. Example *. The client is not connected to a Wi-Fi network, there are issues with the client's internet service provider, or there is a general network outage. 5. Proxy configuration problems *. Problem *. The proxy server is misconfigured, unavailable, or requires authentication. Example *. Incorrect proxy settings, the proxy server is down for maintenance, or the proxy server requires authentication that is not being provided. 6. Port issues *. Problem *. The target port is blocked or not open on the server. Example *. Trying to connect to port 80 when the server is only listening on port 443, https. 7. SSL/TLS handshake failures *. Problem * issues during the SSL/TLS handshake process, such as certificate verification failures or protocol mismatches. Example * the server is using an outdated SSL/TLS protocol, the client does not trust the server's certificate, or the server's certificate is expired. 8. Ephemeral port exhaustion, rare. Problem asterisk the client machine has run out of available ephemeral ports for making outgoing connections. Example asterisk a very large number of outgoing connections are made in a short period of time without properly closing the connections, leading to port exhaustion. This is rare in modern operating systems with large ephemeral port ranges. Code example demonstrating new connection error. Let's create a Python script that intentionally triggers a new connection error. Explanation asterisk. 1. Import urllib3 asterisk we import the necessary library. 2. Create pool manager asterisk we instantiate a pool manager, which is the central point for making HTTP requests with urllib3. 3. Define a deliberately invalid URL asterisk we create a URL http://www.thisdomain as notexist12345.com that is highly unlikely to resolve to a valid server, thus triggering the error. 4. Try, except block asterisk we enclose the HTTP request within a try, except block to handle potential exceptions. 5. http.request, get, URL, asterisk this line attempts to make a GET request to the specified URL. 6. Catch max retry error asterisk we specifically catch the urllib3.exceptions.max retry error because new connection error is typically raised as the reason attribute within a max retry error. 7. Error handling asterisk inside the except block, we print an error message indicating the specific type of exception. We also check if the reason is an instance of urllib3.exceptions.newconnectionerror to provide a more specific message. 8. Timeout asterisk a timeout is added to prevent the script from hanging indefinitely while trying to connect to the non-existent domain. A reasonable timeout will allow the script to return an error faster. When you run this script, you will likely see output similar to this. The output confirms that a new connection error occurred because the DNS resolution for the specified host name failed, i.e., getAddrInfo failed. The actual error message may vary slightly depending on your operating system and network configuration. Strategies for handling new connection error. Now that we understand the causes of new connection error, let's explore how to handle it gracefully in your applications. 1. Retry mechanism with exponential backoff asterisk. Description asterisk implement a retry mechanism that attempts to re-establish the connection after a short delay. Exponential backoff increases the delay between retries, giving the server time to recover from temporary issues. Example using urllib3's retry class asterisk. Explanation asterisk. We import retry from urllib3.utility retry. We create a retry object with the following parameters. Total, the maximum number of retries. Set to 3. Backoff_factor, the exponential backoff factor. The delay between retries will be calculated as backoff_factor asterisk, 2, retry_count, 1. So, the first retry will have a delay of 0.5 seconds, the second will have a delay of 1 second, and the third will have a delay of 2 seconds. Status_forCellist, a list of HTTP status codes that should trigger a retry. Common server-side error codes, 500, 502, 503, 504, are included. Connect, number of connection-related errors to retry. Read, if set to true will retry also for read timeouts. Set to false because a read timeout might be due to a very slow server response rather than a connection issue. We pass the retries object to the pool manager. Retry class also allows more granular configuration, such as *method_whitelist, HTTP methods that are allowed to be retried. *raise_on_status, whether to raise an exception when a retry fails. *redirect, maximum number of redirects to follow. To check network connectivity *. Description * before attempting to make a request, verify that the client machine has internet connectivity. You can use external services or internal network checks. Example *. Explanation *. The is_connected function attempts to create a socket connection to Google's public DNS server, 8.8.8.8, on port 53, DNS port. If the connection succeeds, it means the machine has internet access. Before making the HTTP request, we call is_connected, to check for internet connectivity. If there's no connection, we print a message and avoid the unnecessary HTTP request. Important notes *. This is a simplified network check. For more robust checks, consider using libraries like sutil or netafaces for more detailed network information. Also, be aware that relying on a specific external service might create a dependency. 3. Validate hostname and DNS resolution *. Description * ensure that the hostname is correct and that DNS resolution is working correctly. Example *. Explanation *. The validate_hostname function uses socket.getHostByname to attempt to resolve the hostname to an IP address. If the resolution succeeds, it returns true, otherwise, it returns false. Before making the HTTP request, we call validate_hostname to check if the hostname is valid. If the hostname is invalid, we print a message and avoid the HTTP request. 4. Handle proxy errors *. Description * If you are using a proxy server, ensure that the proxy is configured correctly and is reachable. Handle proxy authentication errors appropriately. Example *. Explanation *. We create a proxy manager instead of a regular pool manager, providing the proxy URL. If the proxy requires authentication, you can use urllib3.proxy basic auth to provide the username and password. 5. Timeout configuration *. Description * Set appropriate timeouts to prevent the client from waiting indefinitely for a connection to be established. Example *. Already shown in previous examples using timeout equals 3.0 in http.request. Explanation *. The timeout parameter in http.request sets a timeout for the entire request process, including the connection establishment. This prevents the script from hanging indefinitely if the server is unresponsive. The timeout is in seconds. 6. Logging and monitoring *. Description * Implement robust logging to capture error details and monitor network connectivity and server availability. This helps in identifying the root cause of new connection error and allows for proactive intervention. Example *. Explanation *. We configure basic logging to write error messages to the console. You can customize the logging level, format, and destination, example log file. Inside the except block, we use logging.error to log the error message. For more serious, unexpected exceptions, using logging.exception will also log the stack trace, which is very useful for debugging. 7. Using try except blocks for handling specific exception types. Explanation *. This will catch and handle the new connection error directly if it is thrown. It allows you to handle different exceptions in different ways. Preventing new connection error. While handling new connection error is important, preventing it from occurring in the first place is even better. Here are some strategies. 1. Use a reliable network connection *. Ensure that the client machine has a stable and reliable network connection. 2. Use a content delivery network, CDN, if your application relies on fetching static assets, example images, JavaScript files, consider using a CDN. CDNs distribute your content across multiple servers, reducing the load on your origin server and improving availability. 3. Optimize server performance. Ensure that your server is properly configured and optimized to handle incoming requests efficiently. This helps prevent the server from becoming overloaded and refusing new connections. 4. Implement load balancing. If you have multiple servers, use a load balancer to distribute incoming traffic across the servers. This prevents any single server from becoming overloaded. 5. Monitor server health. Implement monitoring to track server health metrics, such as CPU usage, memory usage, and network traffic. This allows you to detect potential issues before they cause new connection error. Conclusion: new connection error is a common exception in urllib3 that indicates a failure to establish a new TCP connection to a server. Understanding the causes of this error and implementing appropriate error handling strategies is crucial for building robust and reliable applications that interact with web services. By using retry mechanisms, checking network connectivity, validating host names, handling proxy errors, configuring timeouts, and implementing logging and monitoring, you can effectively handle new connection error and prevent it from disrupting your application's functionality. Furthermore, proactively optimizing server performance, implementing load balancing, and monitoring server health can help prevent new connection error from occurring in the first place. By following these best practices, you can create more resilient and user-friendly applications. Remember to tailor these solutions to your specific application requirements and environment.